And the next section deals with regular polygons. If you recall from chapter 1, regular means that they are both equilateral and equiangular. And so the two regular polygons that you guys are already familiar with is an equilateral triangle and a square. And if I ask you to find the areas of these, or if I ask you to manipulate these, you would have other methods for doing it. In the next section, we'll talk about the way to calculate area of all regular polygons. And in this particular case, all I'm going to talk about is how to find the measure of each interior and exterior angle, as well as just talk about a little bit about the anatomy of a regular polygon. Okay, so one thing, or a couple properties that exist in regular polygons. Again, they are equilateral and equiangular. Okay, but the other thing is they can all be inscribed within a circle. And so what that means is, and we found it with triangles, you can construct a circle that passes through each of the vertices for any regular polygon. And this is the property that we're going to kind of look at today as we go through the anatomy of these. So each polygon, each regular polygon, will also have a center. And it happens to be the center of a circle that passes through all the vertices. So the center of the circle is also the center of that regular polygon. And one of the unique things in all regular polygons, and we'll take a look at it here in these two first, is that when you draw in the radii for this circle, the radii are going to break your regular polygon into three congruent isosceles, or whatever number of sides it has, that many congruent isosceles triangles. Okay, so the radii of the circles, or of the center, or of the circle that passes through each vertex, will always cut the regular polygon into n. Again, n is the number of sides, so it cuts it into n congruent isosceles triangles. And so in this triangle we have these three congruent isosceles triangles. In a square, 4 congruent isosceles triangles. And it's these triangles that we're going to use as a reference when we start talking about area. So I just wanted to get you familiar with the terminology. Okay, the last little thing is when you're looking at these reference isosceles triangles, the length of each side of your figure will be designated with an S. Okay, so we kind of look at the legend over here. N is equal to the number of sides, and S is equal to the length of the side. Okay, the last piece that you're going to be using later on, again, we're just introducing it here, is the altitude of these reference triangles. So if you were to look at the altitude of this reference triangle here, we'll call it A. Okay, the word for this in a regular polygon is apothem. Okay, but basically, if you just remember it as the altitude of the reference triangle, okay, it should, again, allow you to remember what that A represents. And so in the square, you're looking at this apothem. And now for equilateral triangles and squares, it looks a little odd because you have other ways to manipulate those problems. But once we get into some of the other figures, so a regular pentagon, it's a little more clear what that's representing. So if you draw in just one of the congruent isosceles triangles, again, assuming this is regular, all sides are equal, all angles are equal. Now, this little reference triangle right here is going to have an altitude or apothem measure of A, The length of each side is s, and the number of sides for this one would be 5. And so those are the pieces of information you need to know regarding triangles. Hey, this is also when we talk about the constructions of these on the Sketchpad activities. I'm going to be referring to these concepts of creating these congruent isosceles triangles around that kind of rotate about the center of that regular polygon.